Let's take a look now at this multi-stage probability problem. Every day, the first supplier will send things to the inspection facility. 2 days a week, we get things from the second supplier. 80% of all of the first suppliers pass inspection, and of the second supplier, 90% passes. So if we select a day at random, what's the probability that two things will pass inspection? Exactly 1 or 0. So first off, we have to worry about which day it is that we're inspecting. We could have a day where there is one batch, or we could have a day where two batches appear. So that first we worry about the K. Now for the first batch, we worry about so this is going to be supplier 1. So supplier 1 pass, and supplier 1 fail. So those are the possibilities for batch 1. That's for the first batch. We also have the same thing for the second batch, or the second possibility. So let me copy that and paste that here. That for the second batch, we also worry about the first supplier passing or failing. We also worry about the second supplier passing or failing. So this time we have a tree that goes 3 deep. So supplier 2 passes, or supplier 2 fails, and we'd have the same arrows for the bottom one. So let me select that. And we put that down here. Okay, so there is the very complex, not very complex, but much more complex than before tree diagram. All right, let's start labeling the arrows. The chance of receiving only one batch from the first supplier is 2/5, as is 3/5. Because 2 days a week we get 2 out of the 5 days, 2/5, we get 2 batches, and the other 3 days of the week, so 3/5, we get 1 batch. The first supplier, 80% pass and 20% fail. Likewise, down here, 80% pass and 20% fail. For the second supplier, 90% pass and 10% fail. So here is the tree diagram for this. Okay, so now that I have all that information, let me eliminate the first paragraph here and bring the second paragraph up. What is the probability that on a randomly selected day, exactly 2 of the batches pass inspection? Well, how do two batches pass inspection? The only way that happens is going to be this number right here in green. So the probability of 2 batches pass inspection will be equal to 0.4, the probability that 2 batches arrive, times the probability that the first one passes inspection, times the probability that the second one passes inspection. So 0.4 times 0.8 times 0.9. So if I multiply those together, I get 0.288. And that's this one right here, 0.288. Okay, let's now take a look at the probability that exactly 1 pass inspection. Well, that can happen here. 1 passes. Also, 1 passes here. The first passes and the second fails. Also here, the first fails, but the second passes. So I have 3 different ways highlighted in orange where the exactly 1 batch passes. So for this one, it's 0.6 times 0.8, which is 0.48. On this branch, it is 0.4 times 0.8 times 0.1. So 0.4 times 0.8 times 0.1 is 0.032. And for this branch, 0.4 times 0.2 times 0.9. So 0.4 times 0.2 times 0.9 gives us 0.072. And so adding the numbers in orange, I get 0.48 plus 0.032 plus 0.072. So adding, I get 0.584. All right, finally, the probability of exactly 0 successes. Nobody passes. There are two ways that this can be done. The first thing that could be done is to add these up and subtract from 1. That's an entirely reasonable way of doing it. The second way is to do exactly what we did before. 0.6 times 0.2 is 0.12. That way, there's one attempt and it fails. Here, there are two attempts and they both fail. So 0.4 times 0.2 times 0.1 is 0.008. And so 0.12 times 0.008 is 0.128. And I'll let you verify that if you add up these three probabilities, you indeed do get 1 as expected.